Hey everybody, this is Mr. Longo, and in this video we are going to solve two variable word problems. So what we're going to do here is read a word problem, assign some variables, and solve it using substitution or elimination. So Terry wants to make a 40-pound mixture of nuts for her next math party, and she wants the mixture to include peanuts that sell for $2.40 a pound and cashews that sell for $3.20 a pound. And she figures she can afford $2.70 per pound. So how many pounds of each type does she need to buy? Now, the first thing you should do is assign your variables. If you're going to use X and Y, then you should say X is equal to peanuts and Y is equal to cashews. Otherwise, you could just use peanuts plus cashews is equal to 40 pounds worth of nuts. So peanuts and cashews, that makes sense, P and C. But if you choose to use X and Y, please make sure you assign your variables. So this is what I would call a stuff and money problem. That's the stuff. We have nuts, we have some more nuts, and we're going to have 40 pounds of nuts. So we're going to have peanuts plus cashews is equal to 40 pounds of our mixture. But then we need to get into the money part. Peanuts are $2.40 per pound of peanuts and $3.20 per pound of cashews. And that's equal to not $2.70, but $2.70 for the 40 total pounds of nuts, which is going to be a total cost of $108. So Terry must really like cashews and peanuts if she's going to go spend $108. But if that's what she wants to do, let's go figure out how many pounds of each she needs. So I would use either substitution or elimination for this one. Really, the choice is yours. I'm going to multiply the top one by the negative 2.4 and solve this one using elimination. That would give me negative 240p minus 240c is equal to a negative 96. And I'm going to add those guys together, and our peanuts will be eliminated, leaving us with 0.8 cashews is equal to a total of $12. So if we divide both sides by the 0.8, we are going to end up with cashews is equal to 15 pounds. So we have 15 pounds of cashews. Now remember, we need a total of 40 pounds, so peanuts plus cashews is equal to 40. So if we have 15 pounds of cashews, you need 25 pounds of peanuts. Okay, now always make sure you label your answers. Always make sure you answer the question. So you have 15 pounds of cashews and 25 pounds of peanuts. And that takes care of that problem. The next example, there's a little bit of a curveball, and I'm going to give you a tip before I send you on your way to do this one on your own. This is still a two-variable word problem. So you're going to read it and you're going to think for a moment there are three variables. But there's not. There's only two. So pause the video and see if you can handle this guy on your own. So what's going to end up happening? Well, you're going to have eggs. We have 2 egg breakfasts with hash browns and toast. And we have 1 egg breakfast that still comes with hash browns and toast. At many restaurants you go to, no matter what you order, you get a side of hash browns and your choice of toast. So really, what's being charged here is the number of eggs. So we have eggs. That's one of our variables. And the other one goes together, hash browns and toast. So you can call it H if you want to. You could call it S for sides if you want to. Or again, you could say that eggs are X and hash browns and toast is Y. As long as you assign your variables, you could pick whatever you want. So here we go. You have a 2 egg breakfast with hash browns and toast. So you get 2 eggs plus an order of hash browns and toast. And that's equal to $1.85. And then if you order 1 egg with a side of hash browns and toast, you are only charged $1.35. Okay, so again, your choice. I'm going to just use elimination. I'm going to multiply this guy by a -1, so that's just going to make -x, -y, and $-1.35. Y's are going to cancel. X is equal to 50 cents. So eggs are 50 cents each. Now, the hash browns and toast, all you have to do is figure out how much that comes total. Well, if one egg is 50 cents and you have $1.35 total, or if you have $1 for 2 eggs, either way you look at it, you're going to have 85 cents left over for your hash browns and toast. So your hash browns and toast is going to cost you 85 cents. Okay? So that's how you figure out the cost of each. Now those were two very easy, straightforward, simple two-variable word problem. Now we're going to spend a lot of time talking about a multi-stepped, big word problem. And in this one, Luke and Bud are going to go paddle boating down the Des Plaines River. And they're going to head out for a while, and then they're going to turn around and come back. Now, we're going to have two set up equations. We have f of t, which is given to us, is 32t. And then we have g of t, which is -17t plus 510. That's given to you. But what do they mean? F of t is how many meters they are away from the dock on the way out. So as they leave the dock, how far are they? Can be represented by f of t. But once they turn around and come back, it's going to be -17t plus 510. And you might be asking, why is there a difference? Think about current. It's going to be based on the current in which direction they're going. So first we're going to use f of t is equal to 32t, and we're going to evaluate f of 3 and f of 10. So f of 3 can easily be done by substituting 3 into t. So f of 3 is just equal to 32 times 3. That's going to end up giving us 96 meters away from the dock. And then they can do f of 10, which is just 32 times 10 for t is 320 meters away from the dock. Okay, so finding f of 3 and f of 10, it's just evaluating. The exact same thing happens with g of t. So if we have g of 18, we're just going to substitute 18 in for the t. So that's -17 times 18 plus 510. And by substituting that in, you're going to end up with 204 meters. So g of 23, that's equal to -17 times 23 plus 510. That would equal 119 meters. So as you can see, as t gets bigger on the way out, of course, that's the farther you are away from the dock. But as t gets bigger on your way back in, you see the closer it is because you're paddling back to where you were. Okay? So we're going to sketch a graph of what these look like, but we're just going to do a little sketch, okay? This is just a simple little sketch. We're not going to get fancy yet. So, of course, our x-axis is our time away, and our y-axis is our distance away from the dock. And this says sketch the graph. So sketching the graphs, you could always sketch these on your graphing calculator, which is what I'm going to highly recommend that you do. And what it says is to just sketch them with parts of the domain where they do not apply. So obviously we can't go back in time. We can't go negative. So 32t, that just starts at 0, 0. We know another one of our points would be at 3,96. So when we're out for 3 minutes, we're already at 96. When we're out for 10 minutes, we're all the way out to 320 meters. And really what we're doing is we're sketching a graph. That's all we're doing. And I'm going to show you why that dotted line doesn't apply, because when we're on our way back, we start way up at 510 and go down with a slope of -17. And then we're just sketching. It's going to look a little something like that. Now, how did I know exactly where all those were? I don't. I'm sketching. But what we're trying to do is just kind of brainstorm what's happening. You go out really fast at a rate of 32 meters per minute. But then on your way back, it's 17. But we're getting closer to home. And the crucial point is, where do you turn around? So that's the main point of this graph, is where do you end up turning around? So anything after that turnaround or before that turnaround for the light blue graph really doesn't apply. That's where the dashed lines come into play. Okay, now we're going to go find some more of those crucial points, and we might come back to the graph to label them as we need them. Calculate the point where the graphs intersect. Okay, two choices. Choice number 1, type 32x into y1 and type negative 17x plus 510 into y2 of your graphing calculator, and go use the intersection feature by pressing second trace and calculate where they intersect. Your graphing calculator will tell you that that point is at approximately 10.408. We're going to round to 3 decimal places, and then 333. Now, if you did not know how to use your graphing calculator, just set these two equal to each other. Remember, this is just a system. So it's like we can use substitution right here. We would just substitute the y in. So we have 32x is equal to negative 17x plus 510. Add 17 to both sides. That's going to give you your 49x is equal to 510. Divide both sides by 49, and you're still going to end up with 10.408. So see, your calculator knows what it's doing. But then you would have to substitute that back into 32 times 10, and that's how you're going to end up with y is equal to 333. So either way you do it, you're going to find that the point that they intersect is at 10.408, comma 333. And part E says what's happening in the real world at that point. And that's the point that they turn around. Okay, so that's the point. So they're going to go out for 10.408 minutes at a distance of 333 meters, and they're going to turn around and start heading back. So at what time do they arrive back at the boat dock? So that would be when their distance is 0. So this is going to be our x-intercept. So this is going to be something, comma, 0. So, something, comma, 0. Again, go back and look at your graphing calculator and find where it intersects the x-axis, or just think about it in terms of distance. This is on the light blue line, so you're going to use negative 17x plus 510 and just set it equal to 0 and find out when they'll be back. So subtract 510 from both sides, you get negative 17x is equal to negative 510, and you will find that x is equal to 30 minutes. So they arrive home at 30 minutes. That's how long it takes them to go out and come back. Alright, so that's all the easy stuff to this problem. Now let's go play with some of the tough stuff. So assuming they were going the same speed through the water for both parts of the trip, did they start going upstream or downstream? Now their speed is how fast they're paddling. Okay, so justify your answer. Well, let's think about this. How long did it take them to go out and turn around? It took them 10 minutes, or 10.408 minutes to be exact, going out. But it took them a total of 30 minutes to do the whole trip. So just subtract 10.408 from 30 total minutes, and you will find out that it takes them 9.5 or 19.592 minutes to come back in. So were they going downstream on their way out, or were they going upstream? So what we're going to do is just think about it. It only takes them 10 minutes to get out, but 19 minutes to get back. So, on their way out, they're going downstream. So obviously on their way in, they're coming back upstream. So what is the speed of the current? That requires a good old-fashioned formula as distance is equal to rate times time. So first we're going to calculate the out speed. So on our way out, the distance is equal to the rate that you're paddling plus the current speed times time. On the way back in, your distance is equal to the rate that you're paddling minus the speed of the current, because you're now working against it, times time. Okay? And now we know some of this information already. So now we're just going to substitute in some of the information we already know. So we already know the distance they turn around is 333 meters. And that's equal to, we have our rate plus the current and our rate minus the current. But we also know the time. The distance to get out there was 10.408 minutes, or the time to get out there, and the time to get back was 19.592. And from here, all we're really going to do is solve yet another system. So what you would do is 333 is equal to, distribute this into both, 10.408 R plus 10.408 C. And distribute this into the second one, so we still have the same, but we have 19.592 R minus 19.592 C. And then, again, use any solving method that you want. And we're going to find that R is equal to 24.505. That's the rate that you are paddling. So the current is equal to 7.514 meters per minute. So that was a complicated one. That was an example of a big dog Honors Algebra 2 trig problem. But again, it's just multi-part, and you just take what you know with the equations and just keep on applying it. So after that one, this is Longo, and I'm out. See you, bye.